Adapter views such as spinners are able to display views that represent data stored in a collection, generally, such as an array or an array list. They do this through the use of an adapter that basically acts as a view generator. Whenever the adapter view needs a particular view to be generated for a specific element in the dataset, it does a series of function calls on the adapter, providing the index and having that view be generated and returned by the adapter, which the adapter view then displays. Android makes available to us some predefined, pre-built adapters. However, those adapters are very rigid in how they perform because the views that are generated are predefined. If you need custom views to be displayed by your adapter view, then it becomes necessary to create your own adapter in order to have full control over what the final view looks like. Creating a custom adapter can be done in a few ways, but eventually it comes down to creating a class that has implemented the necessary interfaces depending on which adapter view will use this adapter. One of the most straightforward ways to approach building a custom adapter is to simply extend the pre-existing base adapter class that is a part of the Android framework. Basically, the job becomes first, extend the base adapter, and then override the set of functions that are defined there. Namely, you would override the getCount function, which is to return the number of items in the dataset. You'd return getItem, which is the function that will return the item found in a dataset at the specified index. getView is a view generation function, so it will return a view that matches the data element of the provided data element position. And getDropDownView is similar to getView, except this is a view that gets displayed in a spinner when the user hits the what is traditionally presented as a down arrow, and it presents a list for the user to select one item from that list. So we'll see the difference between getView and getDropDownView in this example. So let's actually dive into it and look at a very simple example of building a custom adapter to generate custom views. So here we have an application that right now just contains a spinner, which is of course our adapter view, and it has the ID spinner. And here I actually just have a generic view object, literally the view class, which I'm going to use as sort of a canvas to display a selected colors that I will pick from the list. In my activity, so far, all I have is an array of color strings. This could, of course, be an array list if I wanted to allow the list to be changed or have elements added or removed. But this will be based on a fixed list. So the first thing I'd like to do here is, well, wire up my view elements. So I will get a reference to my spinner. And then I'll get a reference to my, let's call it my canvas. Now that I have that, my goal is to give my spinner an adapter so that it can display the elements from colors. Now, if I did not need a custom set of views generated, then it would be sufficient to just use something like an array adapter here, one of the predefined adapters available in the Android SDK. But because I want to manipulate, or I want to deviate from the standard view generation, I'm going to have to create my own custom class. So what I'll do is, and I'll just do it in the same file just for expediency, I'll create my class and I'll call this class color adapter. And color adapter will extend base adapter. Now, because it's extending base adapter, I'm going to have to implement a set of functions, specifically the functions that were mentioned earlier: get count, get item ID, and get view. Now, before I do that, I want to actually modify my adapter to accept a few items as constructor arguments. The first thing I'll want is a context object. The reason I'm going to accept a context object is that I'm going to generate a set of views, and in order to generate views, I need access to a context object. Alternatively, I could inflate a predefined XML layout, but either way, a context object would still be necessary to perform that action. So I'm going to request a context object. And the next thing I want is the actual data set, the collection of items. So I need, in this case, my colors. And then I'm going to store those as properties. So should have had the underscore. Now that I have these items, I can start completing the implementation of these functions. The first one, get count, is easy. If you want to know how many elements are in the collection, then I'll simply tell you by returning colors.size. If you ask for an item in the from the collection, then I'll return to you the item at the requested position. A call to get item ID is usually only useful, or the only useful implementation is if the data that you're operating on is structured in some way. Maybe if your view, your adapter was pulling elements from, say, a relational database or something where you have an associated row with an ID. Otherwise, it's sufficient to just give a rudimentary implementation here. So maybe I'll just return the long version of the position that you requested. I've seen implementations where you just return 0, but of course that would mean every call would return 0. It's not something we're going to use. So again, any rudimentary implementation here should be fine. And next we have getView. Now, this is where we need to actually do some of the heavy lifting. This is where we're going to generate the view that gets returned to the caller. In this case, the caller would be the adapter view, or the spinner specifically in this scenario. So let's start out simple. What we'd like to do is to have a relatively close approximation to what the array adapter would normally do, which is just generate a basic text view. Once we have that basic implementation going, then what we're going to do is modify it such that the text views generated by our getView function will actually have a color. So you will see not just the name of the color, but the color itself as the background to the text view. So that's what we'd like to get to. So let's start by actually just generating our views. So the first thing I need is essentially a text view. I can create a text view by simply passing in context to the text view constructor. Now that we have this text view, let's set some of its properties based on the item in the collection. So probably the first and most obvious thing we can do is set the text value. So I'll set the text view's text value to be the color at the given position. I know the text size is a little small, so I'll increase the text size to be a little larger, maybe 22. It's a float. And I'll set the text padding let's do it all together. And all right, so that's 5 at the left, 10 at the top, nothing on the right, and 10 at the bottom. So we should have about 20 pixels between any two elements. And now that I have that, I'll return the text view. So that's my returning the view to the caller, i.e. returning this view to the adapter view. And this is a very basic implementation. We should get something. So let's actually try it out. What we'll do is we'll give the spinner an adapter. And that adapter will be an instance of color adapter, where we're going to pass in an instance of context, that is a reference to the activity, and we'll pass in the colors. And then we can run this program. And see what we get. And here we have our list of colors, again with the correct size and padding. So this gives us something that is not exactly, but close enough to what we would have gotten if we used the array adapter. So first thing I want to do here is, again, differentiate it. This is the whole reason we came up with the custom adapter in the first place. We want to make sure that this looks a little different from the array adapter. So what I'm going to do is I'm going to have each of these text views take on a color or background color that matches the color's name. What we're going to do is we're going to modify our text view's background color to be the color of the given position. Once we've done that, I can run this code. And the result is we can see the specified color is used to color the background of the item. Now, even though our getView is functioning as it should, there is one optimization that we must add. And that is, we need to recycle our views. The problem we're having here at the moment with our implementation of getView is that getView right now is creating a new text view object every time getView is called. You could imagine that this colors array might have had 1,000 elements. And as the items are being displayed in a spinner and the user is scrolling, the adapter view, the spinner, would be making a call to the adapter at least once for every item in the list. With our code written as is, every time getView is called, we would be generating a new view, which then, if the user is scrolling quickly, you can imagine, would be at least 1,000 calls, potentially more if they're scrolling back and forth, because each time a view enters the adapter view's viewport, each time it becomes visible, that view has to be generated. Now, when the adapter view makes a call to getView, it passes in a set of arguments that is actually designed to allow us to fix this problem of creating a new view each time getView is called. And instead, we're given an opportunity to recycle a view. The first argument is, of course, the position of the element for which we are creating a view. That's a given. However, the second element is actually a view item that may or may not be null. The idea is, every time getView is called, the adapter view may pass in a previously created view object that we are asked to recycle, we're being asked to reuse. So if this element is not null, then we should, instead of creating a new text view object, use this element, and instead of creating it, we just update its attributes to reflect the view for the element at this position. So let's take a look at what that means. Essentially, the first thing I need to do is determine whether or not I need to create a new text view object. So my text view variable is going to be initialized with either a new element that I create, or we're going to recycle this view if one is available. So the idea is we can basically check whether or not convert view is null. If it isn't null, that means this actually is a previously used view. That is, it is a text view object, because our getView only returns text views. So only a text view would be passed in as a recyclable object. Then what we need to do here is specify that our text view variable is going to take that convert view, but we're going to cast it as a text view. If, however, it is null, convert view is null, then that means there is no text view object, and we can go ahead and create one. So this is what's going to happen. This else condition is what's going to happen the first few times that the getView function is called, because at that point the adapter view would not have, well, the adapter would not have generated any views as yet, because the adapter view would only have just started making calls. But once it has made enough calls such that it has enough views to fit within the visible area of its drop-down list, plus one or two extra elements for optimization purposes, after that, convert view will almost always be not null. And at that point, we will just keep recycling views and no new view objects will be created. That means even if we are cycling through 1,000 elements, we may only have 9-10 view objects in memory, and they're simply having their attributes updated to display the new elements. So here we're creating a text view, and to optimize this, of course, what we want to do is set some of the attributes only when we create a new view, since a recycled view would automatically have those, would have already had those attributes set. So things like the text size, things like the padding can be placed in our condition. But regardless of if it's a new view or a recycled view, we do want to update the text and we do want to update the background. Now, when we take a look at this code, there is actually no visible change. However, this Spinner's use of the adapter is far more optimized. And if the user had a much longer list of elements to scroll through, it would greatly reduce the likelihood of any sort of stutter or slowdown in the user interface. So this is the proper implementation of a custom adapter. You are encouraged, even if not forced, but you certainly are encouraged to implement the recycler pattern. The last thing we want to do here is differentiate between the getView function of our custom adapter and the getDropDownView, which is a separate function. In a spinner, the getView function is what is called whenever an item is selected. The view that you see here is a result of getView. The result of the views that you see here are based on a call to getDropDownView. By default, a base adapter's implementation of getDropDownView simply makes a call to getView, which is why the view that we create here is what you see when the selection is being made. If we did not want that, if we wanted instead to have the views that are presented to us look a little different than what the view looks like when it is finally selected, then this is where we would make one of the modifications. Basically, this is where we can specify what we want the user to see when it's in selection mode versus what they see after an element is selected. An example of when that might be useful, you could imagine maybe a spinner that shows the user, maybe it's a contact list or showing members or employees in a department, and perhaps in a drop-down selection mode, the user would be presented with the employee's name and the employee's picture and the department, etc. But once the item is selected, once that employee is selected, only their name should be visible. So the additional details is only presented when it's in drop-down mode, or vice versa. So we can differentiate those two modes by simply overriding the getDropDownView. So we can do a relatively simple version here. So this is making a call to the superclasses version of getDropDownView, which, as mentioned, by default, is really just invoking getView. That is how a base adapter's implementation is set up. Now, the easiest thing that we can do then is simply take that view and we could change it. We could modify it however we see fit. For example, let us say we wanted to, just again for the sake of differentiating, we wanted to make the text size somewhat larger or change the background color. So changing the background color would simply be setting the background color to be something else. Maybe we set it back to transparent or set it to white. I think we actually have a white already there, so that one of course will look unchanged, but nonetheless I'm just applying this call to the view that is returned from my call to the superclasses getDropDownView function, and then changing its background color, so making this slight modification. The result of that is when an item is selected, I of course will see the color, but when I drop the list down, everything is white. It's modified via the change made in getDropDownView. But then again, when I select, I see the selected color. And again, I could do the reverse here. I could have had the drop down show me the color by simply having this implementation in getDropDownView. So that's the basics of developing a custom adapter. The last thing we'd like to do then here is of course show that once that item is done, once the custom adapter is done, we can use it along with our adapter view as we would with a regular array adapter. So that means I can use on item selected listener in the same way. There is no difference between using my implementation and using the SDK's implementation of array adapter. So I can give my spinner an on item selected listener. And what we'll have here is, as I would before, I can take the item that is passed in, the item that is selected, which will come to me through position, and then I can make a call to my custom adapter to retrieve the item. So now we actually can see how the black box actually works. So if I wanted to set my canvas's color to the item that is selected, I could take this view and manipulate it in some way, extract the text value that I'd like, but that's not the proper way to do this. The reason is you want to make sure that your application is as decoupled or has as low a level of coupling as possible. So I don't want to assume what this view will look like. It may be a text view today, but tomorrow it may be changed and maybe it's a more complex layout where the text view is an inner element. As such, I don't want to presume that this will be a text view and base my implementation on that. Instead, what I will do is I will go to the parent, which is the adapter view, which in this case will be the spinner, and I will tell the parent to get me the item at position. Now, what is this call doing? Get item at position is a call to the spinner, to the adapter view. But get item at position is actually making a call to get item in the adapter. So now we get to see under the hood what's actually happening. Calling get item then in my implementation returns the string at that position from the colors array. So that is what gets passed to the on item selected listener via the spinner. And I can now cast that or simply convert it to a string since I know that's what it is. And this code can now execute where the selected item shows up in my canvas, which is a view object. So my spinner, as well as my on item selected listener, both operate exactly the same, even though I have provided a custom adapter.